Hello, sir. Good morning.
गुड
हाँ जी,
मॉर्निंग
गुड
कैसे
मॉर्निंग सर।
गुड मॉर्निंग जी ऑल गुड मॉर्निंग कैसे हैं यश रोहित आयुष है ना एंड भास्कर जी गुड मॉर्निंग आज थोड़ा लेट शुरू कर रहे हैं हम लोग MSCI 22 ओके इज देयर एनी डाउट इन द प्रीवियस सेशंस कोई डाउट है किसी को अभी तक इन द प्रीवियस सेशन वी डिस्कस वेरियस थिंग्स but I think that was more related to initial part. Okay, this is today we have the concepts of network security, network techniques, identity management. आप लोगों ने किसी में वो किया है किसी ने AWS पे काम एनीबडी वर्कड ऑन AWS
No, sir.
अच्छा वेल इन दिस केस वी हैव एक बेसिक छोटा सा कंसेप्ट था IAM व्हाट इज IAM इज आइडेंटिटी मैनेजमेंट या ना एक्सेस मैनेजमेंट आप लोगों ने सुना होगा देयर इज अ कंसेप्ट कॉल्ड UAS इसे हम कहते हैं यूजर ऑथेंटिकेशन सर्वर्स. So whenever we have a user authentication server, what does it mean? It means as in the corporate we have multiple applications. So whenever you have a various different types of applications, and every time for every application you cannot make multiple authentications. So जब multiple authentication का काम है तो बार बार नहीं बनाना होता है. It's better you create a one UAS server, that is user authentication server ready करते हैं. जनरली उसमें मैंने आपसे डिस्कस भी किया था देयर वाज अ प्रोटोकॉल कॉल्ड LDAP, लाइट वेट डायरेक्टरी एक्सेस प्रोटोकॉल. देयर आर वेरियस डिफरेंट टाइप्स लाइक AD में हमने डिस्कस किया था एक्टिव डायरेक्टरी विंडोज में जो हम बनाते हैं यूजर्स, ऐसे यूनिक्स यूजर्स या कुछ वेबसाइट्स वगैरह में हम लोग जैसे डेटाबेस सर्वर्स ले लेते हैं फॉर यूजर ऑथेंटिकेशंस. आप माई एसक्यूएल लेते हैं, एसक्यूएल सर्वर्स लेते हैं. So these are the areas where you can identify that we have a various different ways to authenticate the user. So user authentication servers बनते हैं and वो क्या उनका फायदा क्या है, पर्पस क्या है, like the moment you prepare these servers, the same user ID password can be easily compliant in their various different applications. So whenever you open a site, like especially even in Google, like you have YouTube, Google Maps, then search engine, Gmail, Google Docs, then this research work in, so that is Colab in .google.com. So there are various different projects. I think more than 200 plus different applications are there with Google. And how they Google authenticate we all. So basically our email ID is not an email ID, that has been a record in the LDAP servers. So backend में LDAP servers होते हैं, same authentication होता है, and that username password is applicable to all their applications. जहां जहां उन्होंने सर backend में क्या करना होता है, LDAP configure कर देते हैं. So they basically share that LDAP, and on that basis further they try to uh, authenticate all the users. यही कंसेप्ट आप क्लाउड कंप्यूटिंग में आप देख पाएंगे. जैसे IAM मैंने वर्ड बोला ना, आइडेंटिटी एक्सेस मैनेजमेंट होते हैं, ये क्लाउड कंप्यूटिंग में AWS वगैरह आप जब यूज करेंगे, सो ऑल्सो यू कैन सी दैट द वे हाउ दिस आइडेंटिटी मैनेजमेंट वर्क्स, राइट. सो ये सबका कंसेप्ट यही है कि पर्पस क्या है, ऑथेंटिकेशन. सो ये ऑथेंटिकेशन अब ऐसे ही हम इन्हें नेटवर्क्स में भी लेना चाहते हैं. सो डिफरेंट लेयर्स, डिफरेंट मॉडल्स, और व्हाई नॉट ऑन लाइक वायरलेस. तो ऑथेंटिकेशन मॉडल्स में आपको पता होगा अब ऑथेंटिकेशन बहुत तरह की है ना. टू फैक्टर ऑथेंटिकेशन, मल्टी फैक्टर ऑथेंटिकेशंस। आपने और वो सुना होगा पहले जो हमारा विंडोज लॉगिन होता था स्पेशली ऑन नेटवर्क, तो जब नेटवर्क में लॉगिन होता है तो देयर इज अ सर्विस कॉल्ड कर्बरोस। सो एक्सप्लोर दैट, देयर इज अ कंसेप्ट कॉल्ड कर्बरोस आल्सो देयर। इसमें हमारा एक कंसेप्ट और है क्रिप्टोग्राफी, सिक्योरिटी प्रोटोकॉल्स। ओके, I think we already discussed about this. Have you heard about this denial of service attack? चलिए आज आपको एक बढ़िया सी बात बताता हूँ। क्रिप्टोग्राफी है आपका इसमें, और इसमें ये चीज़ें हैं। जस्ट गिव मी अ मिनट, आज आपको कुछ प्रैक्टिकल देखते हैं, कुछ अगर अवेलेबल तो। आप में से किस किसने क्रिप्टोग्राफी पे कोई काम किया है? देयर इज अ कंसेप्ट फॉर क्रिप्टोग्राफी आल्सो। सो हाउ
नो
मच?
सर।
हाँ जी, आयुष किया है आपने?
नो सर।
अच्छा, ओके। सो ये टॉपिक आज का आई थिंक काफ़ी इम्पोर्टेंट है। विल टॉक अबाउट क्रिप्टोग्राफी, विल टॉक अबाउट देन डॉस एंड डीडॉस अटैक्स, राइट? तो आज ये वाला पार्ट हम कवर करते हैं। देखो, डॉस एंड डीडॉस एंड क्रिप्टोग्राफी एक एक करके इसको लेते हैं। फर्स्ट लेट अस टेक concepts of DOS attacks, and then we also have a one more topic I said, हाँ cryptography। चलिए ये मिल ही गया मेरे को, फाइन। So I'm just going to share the screen। हाँ जी, yeah, so let us start। Basically, what is the concept of cryptography? Let us start with that cryptography। Can you see the screen?
Yes, sir.
यस।
Perfect। देखो, क्रिप्टोग्राफी का कंसेप्ट है क्या? फर्स्ट वी नीड टू अंडरस्टैंड, whenever we talk about the concepts of security, So security is to be implemented always and always based on one of the most important pillar of cyber security. Also we talk about generally confidentiality, then we'll talk about integrity and availability. So CIA, three major pillars, three major principles of cybersecurity, that is confidentiality, integrity, and availability of the data. But how you can apply the confidentiality on it? Let us assume if I'll discuss something with you where the word called, let's say if I'll say Ola, what is Ola, right? If I'll discuss something with you like I'm saying to you Ola, is it Wallah, Ola, or what? So probably it sounds like Arabic language, or is it Spanish, or is it Urdu, or which language I'm talking all about? Can anyone answer this? What do you mean by the concept called Ola? What is Ola?
Sir, Ola?
Okay,
Hello.
I'll
Hello का
spell. No, I'll spell
opposite.
it. The spelling, what I want to convey is Olleh. Olah.
It's opposite of hello.
Right. This is actually the opposite of hello. Array,
Yes,
it's
sir.
HELLO. And what I'm saying, OLLEH. So it's quite easy that try and understand whatever I want to convey. I want to say hello to you. And this is what again in this image also, if you can see, there is a plain text is called hello. But I tried to create a one ciphertext called Ola. Can you see this? Ola. Now, if you pronounce, how you'll pronounce? You'll obviously pronounce it's Ola. So the concept is that whenever we talk about the data transmission and we want the confidentiality in any data, so what is the best practice? The best practice is we have to convert that data into another format, unrecognized format, and that unrecognized format called as ciphertext. What is it called? Ciphertext. So the ciphertext is hello, right? A plain text is hello, and the ciphertext is Ola. Is that clear? What is it? It is called as Ola.
Yes, sir.
So major part which we have to understand, one is plain text. My plain text is hello. I have to do something on this plain text, because in case of networks also I want to transfer my data, and in case if somebody can hack my data, and if my data is in the plain text, that could be compromised. So how can I secure my data before I'll get compromised? So it is highly recommended on the source side, on your device only, you convert your plain text into the ciphertext. What is it? It's called as ciphertext. So convert your data into a ciphertext. Okay. And once your data is in ciphertext, from the ciphertext, now further you have to convert your data back to the plain text. So there are two methods. Try and understand, there are two good methods called encryption and decryption. Right? So there are two methods called encryption and decryption. So the concept is like you can try and understand and just take a look on the spec. So there are two methods. There are two good methods, and these method called as encryption and decryption. So in your theory, please take my words, probably not only in one subject, even in multiple subjects, in multiple examination, you must get this question: what is cryptography and types of cryptography, and there are various different ways to get the questions related to cryptography, right? So what is this all about? Try and understand. First, my concern is I have a plain text. So I have to create my data and convert my data into the ciphertext. And from ciphertext, finally on the destination, I need to convert back to the plain text. So how can you convert the data from plain to cipher or cipher to plain text? Right? That's a concern. So in this way, there are might be you will get a क्वेश्चन हमेशा आएंगे. देखिए क्रिप्टोग्राफी इज वन ऑफ द raw subject, right? It is one of the basic subject of cyber security. तो ये तो आएगा ही आएगा, ये कभी रुकेगा नहीं, ये याद रखिएगा, राइट? हाँ, वो असाइनमेंट्स हो या कभी भी साइबर सिक्योरिटी को कोई भी सब्जेक्ट हो, इट इज नॉट ओनली रिलेटेड टू 22, इवन इट कैन बी possible in 23 MSc 23 or even in 24 or many other. Yeah, okay. So now let us try and understand the first method called cryptography. What is cryptography? And first method is encryption. So always remember there are two good methods. First is encryption and second is decryption. Now what is encryption? Encryption is a technique to convert your plain text into a ciphertext. So just look it very carefully. There is a method which is clearly saying that ciphertext is equals to if you can see from the left side, ciphertext is equals to encryption method, where we are going to pass some parameters. And what are these parameters all about? The parameters are, first, I need a plain text. Second, I need some algorithm. Now, what are algorithms? I'll explain more in detail. And third is basically a concept called as key. Now, what is key? Key is your password key, or it could be any other type of key. So the way of authentication
to process that algorithm is the concept basically called as key, right? So three good parameters. The first one is your plain text, because we have to create the ciphertext. So first is your plain text. Second is algorithm. And third is key. So algorithm could be any other, right? We'll talk about more in algorithms. So finally, we are supposed to create a one of the content, and that content is nothing like Ola. So we try to create a ciphertext, right? I'll give you more examples. The examples like how we are supposed to make some changes and various different algorithms where we can make more complex ciphertext, right? So what is the best practice? The best practice is there are many standard algorithms, or even we can customize the algorithm as well. I will give you the way. Even you can write your own code. You can create your own algorithms to convert your data. I believe that is one of the question in your theory as well as in practicals as well. That will give you some mathematical or logical operations, and on that basis, you are supposed to encrypt and then further decrypt your data by using any code or by using any code or by using any third party application. That is fine. Right. So the first method is accept the data as a plain text, apply encryption algorithm, create ciphertext, and then further transfer that data into the onto the network, so that your data is quite secure and you will not face any inconvenience to transfer that data. The next part is once you created that data, so once you have created that data, now we are supposed to transfer the data into the destination side, and on the destination we have to again need my data which is in the plain text. So to get that data into the plain text, the best practice is again we need to use another method called decryption. Now what is decryption and what are the parameters in decryption? You can see. So finally we have to generate plain text. So you have to write plain text is equals to decryption, and we have to pass some arguments in decryption. The first is again your ciphertext. Now because we already have the data in the ciphertext form, so we have to take a ciphertext. Second, we have to take the data. That is again algorithm for decryption. Even it is possible that you have a different algorithms for encryption and decryption. And third, again to decrypt your data, third option is again you need key, because you want to execute an algorithm, and to run an algorithm for decryption, probably that algorithm is same same as encryption or decryption. So you need a key. The key must be different or same. That depends, because in that case, we have to understand the concepts of what are the different types of cryptography. So once you are through with the cryptography, the types of cryptography, you can easily able to understand how it works, right? So that is one of the way to understand. Okay. So we need three different types of concepts of cryptography. So the concept of decryption. So in this case of decryption, we can use multiple algorithms again for decryption, right? So two good methods always used in the cryptography. One is encryption, second is decryption. Right? So now let us talk about, there are two different types of cryptography. Although it's not type, there are multiple functions, but generally there are two different types called symmetric cryptography and second is asymmetric cryptography. Now note down please. So there are two major types. First is symmetric, second is asymmetric. And there are various other methods of cryptography. So I want to show you something live, some practicals also, that how people used to deploy their data, create the ciphertext, and how we'll try to identify the data. Right? So there are various different methods by which we can able to analyze our data. So what is this cryptography all about? I think now the concept is quite clear. So please note down there are two different types. First is symmetric cryptography and second is asymmetric cryptography. Right? First is symmetric, second is asymmetric. Now what is symmetric cryptography? Please note down. Symmetric cryptography is a technique where we have a common key. We have to pass three parameters. The first one is your plain text, second is your algorithm, and third is your key. So what is key? Key is nothing, as I told you, it could be one of the way of authentication. So we have various different methods of authentication, right? So that key could be one of the part of authentication. Okay. So in authentication, now if you have a common key, it means there is a one single password. So in one single password, That means one single key. So if we have one common key, the common key is used for encryption and decryption. For both, we have a common key. Right? So we have a common key for using the method encryption and decryption. It's just like a lock at the home. We have the lock. So in case of lock, what happened? We have a common key to use to lock and unlock any door. So basically, that kind of key used for encryption as well as for decryption, which must be a common one, right? Such type of cryptography called as symmetric cryptography. So at least note down few common algorithms like DES, AES. These are the common algorithms, standardized algorithms, especially used for symmetric cryptography. So first is DES, that is called as data encryption standard. Then we have AES, that is advanced encryption standard. Another you can note down IDEA, IDEA, DES, triple DES. So there are multiple algorithms, standardized algorithm, where to execute those algorithms, we can use a common key. So that comes in the symmetric cryptography. Right? So in such scenario, we need to use a common key. We can even customize our own algorithms. I'm just going to show you the way how we can work.
Yes, Rohit, ये hash values को भी और भी discuss करते हैं. Just फटाफट ये वाला part खत्म करो. So there are two good methods. Understood? Encryption, decryption. How your plain text to be converted into the ciphertext, and again cipher back to plain text. So this is a basic method of cryptography. In case of symmetric cryptography, you have a common key. So if there is a common key to transfer your data, right? So to transfer the data and to encrypt or decrypt, what we want a common key. Now how to work with a common key? So in common key, that it could be considered as a passwords, और जैसे मैंने आपको algorithms बताया that you can use DES, triple DES, IDEA. These are the algorithms which you can try and you can use, right? Next, now let us talk about some more algorithms. देखो algorithms में क्या है, एक ये concept clear हुआ पहले. What is the common key issue in case of ciphertext? What is common key? So I think this common key concept is clear to all, right? What is the way how you can convert your data? For that, I need to run an algorithm. Now to run an algorithm, what we need? I need a key. A key always must be common, where the algorithm may be different while encryption or decryption. So algorithm may be different, but the key must be common, right? So this is one of the way how it works, how you're going to transfer your data from plain to cipher or cipher to plain. Next. So in this scenario, again, we have another concept. which is called as asymmetric cryptography. Now, what is asymmetric? Just take a look. What is asymmetric cryptography? Now, in case of asymmetric, there are two different keys. So there are two different keys. For every user, there must be some keys. So I hope you must heard about like HTTPS. You might heard about your DSC, digital signature certificates. DSC. DSCs are basically a digital signature for each user who represent any organizations or so, right? So you must have a concept of DSC, that is digital signature certificates, right? So there are many different ways to understand how you will find these DSCs. ये भी अभी बताने लगा हूँ, आगे लिखिए फटाफट. Now remember, in case of asymmetric cryptography, there are always two keys. तो दो अलग अलग keys होंगी ही होंगी, right? So what are these keys all about? Like for source, again they have a two keys, and the two key combination is first is private and second is public key. So it's a key combination model where every user must have a private and public key. इनका combinations and working methodologies हम change कर सकते हैं, right? Because let's say you have a relationship model of one to one, one to many, many to one, or many to many, right? So there could be a different relationship model, and accordingly we can make some changes of the combinations of source and your destination keys. That is nothing but a private key and a public key model. So in case of private key and public key, so every user have two keys. One is your private, and second is public key, right? Same for the source as well as same for the destination. Now let us take an example. जैसे आपने देखा होगा, there must be an example for banking. So you must have seen in the case of banks, where in the case of bank, you must heard about like आपने lockers कभी issue करवाए हैं बैंक में? So in case if you issued a locker in the banks, you must have seen that there are two keys. One key is always with the customer, and second key is always with the bank. So there are always two keys, right? There are two good keys. One is for the bank, and second is with the customer. So if you really want to operate your locker, what is the best practice? You have to apply both the keys, right? You have to apply both the keys. Okay, so once you apply both the keys, then only you can operate the lockers. Iska matlab, there is a two key combination model. By using any single key, you cannot operate even your lockers. Okay, same way, same method, like we have a concept of two different key model. Now let us take a scenario where one-to-one relationship is there. Okay, we'll talk about one-to-one relationship. Now in case of one-to-one relationship, just take a look how it works. So let us say there are two good users. One is Alice and second is Bob. Now Alice want to transfer some data to the Bob. So let us try and understand this case. Alice wants to transfer the data to the Bob. If they will send a data in the plain text, so you know there is a concept of sniffers where users can hijack the data even from the network. So they practice, the best practice is to go with the cryptography. Now, if they use a symmetric cryptography, that is a quite possibility that in case if the hackers can able to trace your keys, they can extract your keys, then obviously they can decrypt your data also, because that's a common key. So there is a security, but yes, that security could be compromised in case if your common key, because it's a common key for the source and destination, so key can be compromised and be shared to others or hacked by others. So in that case, again, risk level is there, but it's a medium level risk level. High level security, if you'll talk about, confidentiality, if you talk about, and even we want that data is to be only and only be open to the destination, where that destination user, a specific user can only access that data. So if we want to make it user oriented, one-to-one relationship, or even end-to-end is little different. I will explain end-to-end encryption also, but try and understand first of all how the one-to-one relationship model works. So in case of one-to-one relationship, the source will generate the data packet, right, by using two keys. Now what are two key combination? As I said, Alice. Now let us assume Alice have two keys. One is private key and one is public key. And I have another user called Bob where they also have a private and public key. Okay, so they have a private and public key. Bob also have the same way. Now Alice want to transfer the data to the Bob. So what is the best practice? Now first of all, Alice and Bob, they need to share their public key to each other. Before they go for any transaction, the best practice is they both need to share their public key to each another, right? So what is this public key all about? So they have a concepts of public key transmissions to each another. Okay, so in that case, now Alice, once they want to encrypt their data, they want to generate the ciphertext. While generating that ciphertext, they use a method of encryption. They pass their parameters. The first parameter is again your plain text. Second, they must use some algorithm. Third, now third is the combination of the key, where we have to pass the keys. So it's a combination of the key. So Alice used their private key. Now try and understand. It's a cross connection sort of, where Alice used their private key, and with the combination of the Bob's public key. Bob already shared their public key to Alice. So Alice will apply their private key with the combination with the Bob. So they generate the data, they encrypt that data, apply the algorithm by these two combinations. A is private key and B is public key. B stands for Bob and A is Alice. So A is private key plus B is public key. We want these two keys to encrypt the data and finally to generate the ciphertext. That ciphertext will try to transfer to the other end. Now, if any person who's doing a man-in-the-middle attack or on the network side, they compromise our data packets. Now, to decrypt the data, they need two things. What they need? They need two things. And even that data is not transmitting. And now, first they need what? They need now Bob's private key. To decrypt, they need Bob's private key. And that could be only being decrypted once you have a A's public key. So यहाँ पे दो चीजें चाहिए. We need a Bob's private key and A's public key, because A's private key used in the encryption, and for decryption we need A's public key. And at the same time, for encryption, the Bob's public key used. Now to decrypt, we need Bob's private key. So it's a cross combination. If both the cross combination works practically, you can able to extract the data, you can able to decrypt the data now at that end. It means this data is more like user to user, peer-to-peer connectivity. One user want to transfer the data highly in the secure form. So the best practice is they can transfer their data from one place to other by using private public key combination. इसका practical दिखाता हूँ अभी. Right, try and understand, and then I'll show you all the practicals. I will come to the practicals. Okay, so this is the way. This is a combination of asymmetric cryptography. The most common and very famous algorithms in asymmetric cryptography is RSA, Rivest, Shamim, and Admin. So three good scientists, or we can say generally we used to call it as a hackers, mathematicians, great mathematicians, and the hackers with the mindset, they finally prepared these algorithms, and one of the highest secure algorithm called RSA. So they kept their algorithm name with their names, with their initial letters. So RSA, that is Rivest, Shamim, and Admin. So these three people sit together, prepare this algorithm, and this is one of the most complex and highly secured algorithm. Because if you really want to say that there is a RSA algorithm, and in case you want to decrypt, let's suppose we try some brute force attack or on RSA algorithm. So that was earlier being discussed, that if suppose the RSA is of only 32 bits, right? Actually, it's 32 bits, 64 bits, 128, 256, then 512, 1K, 2K, 4K, 8K. Today we have 8K. Till 8K algorithms we can implement. We can convert our data with the 8K bits encryptions, right? So highly complex data being generated by using RSAs, right? Along with some other algorithms. So there is a combination depending upon what type of data you are transferring. Even you can see the practical. let's suppose we are on this portal, like we are on meet.google.com. So if I'll go and check their algorithm, even in this case, they are using asymmetric cryptography. They are using RSA with AES encryption. So what is HTTPS? And as we have to talk about S is basically digital signature. So the digital signature, you have a specific certificate for this. So if you see this certificate, right, hash values, I'll explain hash values also right now. What is the purpose of these hash values? Before that, just try and understand what is this all about. And if you really check their algorithm, you can see RSA encryption. So you can see there is a RSA encryption algorithms being deployed to transfer your data from server to the clients. So this is one-to-many relationship model. In case of one-to-many relationship model, we don't want client-side key, right? We don't want client-side key. So the private key, there RSA, it means it's a asymmetric cryptography. So if it is asymmetric, that means the private key has already been deployed on the server, where the first time, if the first time my browser is about to explore that website, what happened if it is first time and I don't have the public key of that server? So first, and if it is the protocol HTTPS, so the first time that your certificate, your public key need to be downloaded in your browsers, right? So if you must have seen your browsers, there are a lot of keys. There are many keys available in your browsers, right? So if you go and check your settings, you will find cookies and you will find the public keys. There are a lot of public keys for different websites which you have already explored in your browser. Okay, so there you will find the keys, right? You will identify many keys, many security keys are there. Give me a minute, let me show you in case if I can somewhere. So you will find a lot of keys within your system. Some public keys. Without public key, you cannot even access, or you cannot able to browse your websites. You see managed certificate, SSL certificates. Can you see this? So how many servers which you have visited, or see the keys? Can you see untrusted key, one of the unauthorized key identified in my browser? So these all are the different types of keys you will see, right? So certain list of the, and you can import if you can't able to access some site. So manually sometimes we need to import some public keys in the browsers, or your certificates within that browsers, right? You can able to access your keys. Are you getting my point? So you will find various different keys. There you can manage keys for phone. Okay, this is related to our keys, create pin, sign in and all. Reset your security key. Can you see this? So there you will find many different ways to identify your keys. So every system also have their own keys. Okay, that is which type of keys you are using, depending upon DNS and other entries. You can see the protection, you can see. So basically in every browser you will identify various keys, and without keys you cannot access those websites. So what happened in case if you are talking about any website accessing where your website belongs to HTTPS and it is a asymmetric cryptography, so those keys, the public key downloaded to your browser, first of all the public key downloads to your browser, and once that keys are there in your browser, then further based on those keys we can manipulate, we can able to access, right? And basically it's a cross combination like the private key is on the web server, now public key downloaded in your browser. So whenever you make a request to any website, your system, your browser will generate a request to the web server along with the keys. So public key generated by the public browsers, right? And that request goes to the web server already have their private key, so again they will check the combination, right? So combination of private key, public key matched over there, and then only the data transmitted from that web server to the client's browser. Okay, this is the way, this is the process how things goes across. So you can try and identify, you will find some keys. इसी में होता है. Let's see where it is. Right, so you will find some keys. You can see these type of keys. These all are the, like, I blocked certain site, I blocked some notification, and you can see the sites which I access. So recent activities which I did, I try to block some third party sign-ins and many other, right? So these all are the additional security settings which is being implemented, but you can only access the website once you have those keys. Concept clear hua how that HTTPS works? Yes, is that clear?
Yes.
हाँ, और ये एग्जाम में आएगा, मतलब these types of questions are generally there in your examinations, right? And especially whenever you are on this is what the concept in HTTPS, it's a shared key concept, or public key cryptography concepts, you can say, or this is symmetric key. Shared key is symmetric key because they have a common key. Okay, so just try and understand how this cryptography works. I hope the methods, two different types is clear. First is symmetric cryptography, second is asymmetric cryptography. So this concept must be clear to all. And now I would like to share some more experiments, some more algorithms. There is one more algorithm called Caesar cipher algorithms, right? Now, what are these algorithms, or other basically it is being said that cryptography has been identified or invented by Caesar. Julius Caesar novel was there also on Julius Caesar. So that Julius Caesar, so that Juliet want to transfer some data to that some destination. वो पहले बाज हुआ करते थे and all, है ना? So they want to send that information to that destination, but they know that there could be a man in the middle. So from the network side, the people will gonna extract their data, right? They'll hit to that bird, and they extract that information. Now what they did, they basically try to encrypt the data. They generate a ciphertext in such a way that data being transferred over there, and data being communicated to the destination, and the best part, the man in the middle attack being committed, and even they'll not be able to recognize how that data being transferred and what are that information all about. So that concept started by Julius Caesar. Although if you see our granthas and Ramayana, Mahabharata, and many other, like you must have seen these kind of things, quite ancient. It's not something new, right? पहले तो हमारे यहाँ पे तो आंखों से data transfer कर देते थे, right? Through brain on telepathy, and many other things were also there. So there were many different channels to transfer the data, and that data is all encrypted, and in that encryption data being transferred. But in the real scenario, it has been explained and written in the books that the invention of the cryptography being committed by Julius Caesar, right? Julius. So what is that all about? Let us say try and understand this concept of this method also. In that case, let us take a small example. There is a concept called ASCII codes. Have you heard about ASCII codes? American Standard Code Information Interchange. So there is a concept called ASCII codes, and in that ASCII codes, basically all the keys you pass from your keyboard have their own binary codes and decimal codes. So that is being mapped. As you know, computer only works on binaries, zeros and ones. And in case of ASCII characters, so there are basically it's a 8-bit combination. So total characters are 0 to 255 in your keyboard. Okay, example, let us take an example. If you press uppercase A, if you press capital A from your keyboard, do you know what is the way how computer understand capital A, capital B, or A, small b, or any other combination of the letters? So these letters have a backend called ASCII characters. Abhi Hindi, Chinese, and many other languages are also there, but that called Unicode. It never called as ASCII codes. Okay, so we have two different ways of data expression mode. In your keyboard, there is a concept called ASCII codes, 0 to 255. And every key have their own decimal values, which you can represent and convert into a binaries. तो schools में शायद हमने पढ़ा होगा binary to decimal, decimal to binary conversion, or even in your BCMCA at the beginning sessions, probably you might learn that kind of concepts. So let us assume like now basically what are the standard values? Let us discuss those standard values. Like if you press uppercase A, now if you press uppercase A, the value is 65. What is it? The value, it's a standard value called as 65. Now if you convert the 65 into binaries, then generally the number is 1, then 5 times zeros in between, and then 1. So all 7 bits, right? You can extract from 65. You can try convert your number to binary, right? So everything is in the form of binary. This is the way how computer works, and binary back to a decimal, and these decimal values being represented as a ASCII code and being mapped with your keyboard, so that whatever the keys you press from your keyboard, all the key combination have their unique ASCII code number. Okay, so uppercase A is 65, uppercase B 66, uppercase C 67, and so on. So first 26 letters are there like this. Okay, now if we'll talk about lowercase a, small a, lowercase a, the ASCII code number is 97. Lowercase b, the number is 98. Lowercase c, the number is 99. And lowercase d, the number is 100. Are you getting my point? So 97, 98, 99, 100. In this way, again, lowercase values are there. Even though if I want to say numerical values, let's say 0, 1, 2, 3 and all. Now 0, generally people feel that what is ASCII code for 0? Generally people say, sir, all 8-bit 0. No, it's not like that. If you press 0 from your keyboard, the ASCII code number for 0 is 48. ASCII code number for 0 numerical value is 48. For 1, the number code is 49. For 2, the number code is 50. अगर मैं आपको कहता हूं कि like okay, let us have a class on second floor, और अगर यही चीज मुझे हाइड करके बताना है ना, shall I say okay, come on 50th floor? अब मैं आपको क्या कर रहा हूं, come on 50th floor. अब आप कहोगे 50th फ्लोर, सर बिल्डिंग ही नहीं है 50 फ्लोर की, आप कौन सी बात कर रहे हो, 5वां फ्लोर भी नहीं है, आप 50th फ्लोर कैसे कह रहे हो? अरे आई एम यूजिंग ASCII character because 50 represent 2. So from the keyboard, if you want to press 2, but computer internally understand that you press 50th ASCII code number, which represent your data into any font. आपने आगे fonts लगा दिए, तो कई बार होता है ना, आप A प्रेस करते हो तो अ आ जाता है, different fonts आ जाते हैं, that all are the styles. But आपने Arial font लगाया है, Times New Roman लगाया है, Calibri लगाया है, whatever the fonts you have hardly matters, because the fonts are supposed to represent the character set in your IDE, whatever the integrated development environment or any rich text format applications you are using like MS Word or so. So जो आपको letters नजर आते हैं वो तो एक font की वजह से आते हैं, लेकिन आपने कौन सा letter press किया है, processing करते वक्त अंदर ASCII codes काम करते हैं. So there are certain ASCII code numbers. For more details, you can Google ASCII code numbers and you will find all the key characters over there. Got it? Is that clear? Enter का 13, अभी नॉन प्रिंटेबल कैरेक्टर्स के भी ASCII कोड्स हैं. एंटर 13, एस्केप राइट 27, स्पेस बार 32, राइट for every single key, all wild characters, every single key you have the ASCII code number. तो कौन सा ASCII code number कहाँ use करना है, that is up to you. You can identify, you can process. Right? Now let us have an example. Can't you make a one program, और ये practicals में भी आया हुआ है, by using C language या any other programming language like Python or wherever you are comfortable. By using any language, can you suppose to create the code for encryption and decryption where the algorithm is, let's say we want to create an algorithm where I want a symmetric cryptography, where what I want to do that you have to accept the data from the user, and whatever the data or a file from where you can read the data from the file. So you read the data from that file or accept the data from the user, identify each and every character and just apply the algorithm. Let's say character equals to character plus 3. Matlab, let's say you have a complete MS Word book, a big book of 200-500 pages. Or her letter ko, by letter, if we'll try to recognize wherever it is uppercase A, the value of uppercase A, you know, that is 65. So what you need to do, you have to identify the character code, ASCII code for each characters. From that ASCII code, right, you find the ASCII code number, and from that ASCII code number, let us apply the algorithm. Let's say character equals to character plus 3. Example. So if you press capital A, the code is 65. Now 65 plus 3 becomes 68. So as it becomes 68, okay, and now you represent that character. Now your job is to represent that character. Let's say अभी तक मैंने hello बोला था, hello को आपने फटाफट ओला है पहचान लिया था. Why? Because उसमें मैंने क्या किया था, find the word. वहां मेरी algorithm क्या थी, find the word and just reverse each letter in that word so that it becomes ola. So hello becomes ola, right? So you can able to understand, अरे सर इसमें तो hello नजर आ रहा है. You might identify the pattern, but now let me make some more complex model. Now if I'll say hello and instead of hello if I'll say khoor, what I'm saying to you, khoor. अब ये खूर कहां से आ गया, आप कहोगे सर ये खूर वर्ड क्या है, अरे मैं हेलो बोल रहा हूं. अब कौन सी लैंग्वेज पहचानोगे, अब कौन सी एल्गोरिथम पहचानोगे. So that becomes little more complex as compared to the first algorithm. Now this is in the second experiment, we have a different algorithm. Why? Because in this algorithm what I did, I selected each letter plus 3. So that becomes another letter, like capital A आपने प्रेस किया which is 65, तो कैपिटल B क्या हो गया 66, कैपिटल C क्या हो गया 67, कैपिटल D क्या हो गया 68. It means जहां जहां कैपिटल A लिखा है just convert to कैपिटल D. तो जहां B लिखा है वहां E कर दो, जहां C लिखा है वहां F कर दो. Are you getting my point? So if you convert something like that, so now I got a letters like HELLO. Let me open I think one a sky chart for you. You can see a sky table. All right, so just take a look. So check, let's check, है ना. यहाँ पे क्या है, पहला क्या है लेटर, कैपिटल H. Now if it is capital H, where do we have H? इसमें सारे एक्सप्रेशंस हैं, सारे लेटर्स हैं, सिंबल्स हैं सारे, ठीक है. सो स्टार्टिंग फ्रॉम 0 है. सो आपके जो प्रिंटेबल कैरेक्टर्स हैं वो होते हैं 32 से लेके 127 के बीच में. दीज ऑल आर कॉल्ड एज प्रिंटेबल कैरेक्टर्स. सम नॉन प्रिंटेबल कैरेक्टर्स आर देयर, कंट्रोलर्स आर देयर, ये बैक स्पेस, टैब, शिफ्ट, ये सब कीज के भी कॉम्बिनेशंस हैं, राइट. सो देयर वी हैव अ प्रिंटेबल कैरेक्टर्स, और इसमें हमने बोला H, राइट. सो इफ यू वांट टू रिप्रेजेंट H, देयर इट इज H, ओके. और H का की कोड नंबर क्या है, स्काई कोड नंबर, ये देखिए कैपिटल A का क्या आया था, 0 का देखिए क्या आया था, 48 आ रहा है कि नहीं आ रहा है, 0 रिप्रेजेंटेड एज 48. एंड नाउ इफ आई हैव H, द कोड नंबर इज 72. 72 plus 3, so 74, 75, 70, 75, that is K. plus 3 किया ना, K. तो what I did, In this case, what I did, H is to be represented as K, E has been represented as H, L represented as O, again we have L, we have represented as O, and now O represented as R. तो क्या बन गया, खूर. अब मैं आपको खूर बोलूं तो अब तो आप में से कोई नहीं पहचान पाएगा what I'm talking all about, that I'm saying hello to all of you. Understood what is the practice, what is the way how I'm going to represent my data. So let us assume I just try to encrypt my data. अभी ऊपर क्या था, ऊपर वाला एक्सपेरिमेंट में क्या था, एल्गोरिथम इज सेम फॉर इंक्रिप्शन इवन फॉर डिक्रिप्शन. भाई वहां पे एल्गोरिथम क्या थी, रिवर्ट द लेटर्स, है ना, रिवर्सल. आपका जो रेगुलर फॉर्म है उसी को रिवर्ट कर दो, प्लेन टेक्स्ट टू साइफर, साइफर टू प्लेन. आपने रिवर्ट कर दिया तो इंक्रिप्शन डिक्रिप्शन चल गया. लेकिन यहां पर क्या हुआ, वी हैव अ डिफरेंट एल्गोरिथम, लेट्स से करेक्टर इक्वल्स टू करेक्टर प्लस 3. तो जो वर्ड्स बने वो बना खूर, लाइक दिस इज माय साइफर टेक्स्ट. बट ऑन द डेस्टिनेशन साइड आई नीड डिफरेंट एल्गोरिथम फॉर डिक्रिप्शन. द एल्गोरिथम इज नॉट सेम. Can you see this? In the second experiment, you can understand that the algorithm for encryption is different and the algorithm for decryption is different. क्योंकि encryption के टाइम में हम क्या लगा रहे हैं, करेक्टर इक्वल्स टू करेक्टर प्लस 3, और डेस्टिनेशन साइड पे क्या लगा रहे हैं, एल्गोरिथम में करेक्टर इक्वल्स टू करेक्टर माइनस 3. अरे खूर वर्ड आया था तो उसमें माइनस 3 करो ना, so that you can able to identify the plain text. So this is a small experiment which we can try. ऐसे ही कोई भी आप एल्गोरिथम, कोई भी मैथमेटिकल एल्गोरिथम, कस्टमाइज एल्गोरिथम आप अप्लाई कर सकते हो, वेयर LHS equals to RHS. अर्थमेटिकल ऑपरेशंस पढ़े होंगे आपने, कभी मैथमेटिक्स पढ़ा होगा. So in case if you learned your mathematics in the early schooling, right, where we used to write, you know, LHS equals to RHS, left hand side का रिजल्ट जो है must be equal to right hand side in the arithmetical operations. So any algorithm where you can encrypt or decrypt, where the result must be same for encryption and decryption, if it is anything which is possible, you can use any physics theorem, any mathematical theorem, any other theorem, anywhere where you have any way of expression where you can make your data easily transferable, convertible, transferable, and revert back, and without loss of data, right? That is the best practice to apply the cryptographic algorithms in this. Concept समझ में आया जी, क्रिप्टोग्राफी के algorithms हैं क्या, how the algorithm works? Is that clear to all? Yes, please. Is that clear?
Yes.
परफेक्ट. सो इस तरीके से आपको ये एल्गोरिथम्स रेडी करनी है. यू नीड टू गो थ्रू. प्रैक्टिकल में भी एक क्वेश्चन आया हुआ था, पिछले कुछ पेपर्स आप चेक करेंगे तो यू कैन फाइंड आउट देयर इज वन पेपर, वन एग्जाम वेयर यू हैव टू इम्प्लीमेंट अ cryptographic algorithm for encryption and decryption, or write a code, write a program by using any language and convert your data into a cipher and cipher to plain text. So might be you will face these kind of questions again, because these are the very common things. So this is one of the very small example where you can apply, right? So I think अभी आपको इतना clear हो गया कि what is the architecture and how it works. Now I will show you some more experiments. Practical देखिए कैसे data transfer करते हैं हम लोग. आप में से कौन कौन लोग जो है गूगल ड्राइव पे डेटा डालते हो, इमेजेस, अपनी फोटोज लेते हैं, सेल्फी लेते हैं, एंड यू जस्ट गो एंड पोस्ट इट, एंड यू माइट हैव सिंक्रोनाइज्ड योर मोबाइल फोन्स विद गूगल और एप्पल स्टोर एंड एप्पल ड्राइव समवेयर, राइट, वेयर you take the pics and those pics being automatically synchronized on your backend, right? And what happened finally, you exhaust your memories, because today the size of the images are quite high, right? You have a great megapixel cameras in your phones. So in that case, your space, it occupies a lot, and once you upload and synchronize, you exhaust your memory, and finally you are supposed to pay monthly to Google or to Apple for extra storage, right? So instead of that, हाँ आयुष ये आया हुआ है ना, हाँ string and integer x from the user 40 apply the following algorithm in the string, ये आ रहा है ना, character plus x decryption encryption using C, Java or any preferred language. So this is what the method is all about. So you can try these kind of programs, Ayush. Good, है ना? Understood what is the way how you have to go for it. तो करना कुछ नहीं है आपको, इसमें बस लेटर्स लेने, अगर आप सी लैंग्वेज के अकॉर्डिंगली लोगे, उसमें ना ASC फंक्शन होता है. सो यू जस्ट नीड टू take the data, entire data, place it into the array, collection of each letter, and take a letter by letter in the loop and pick their ASCII code number by using ASC function. ऊपर string.h लगा देना. सो ASC फंक्शन में आप ये इनपुट वैल्यूज डालना, करेक्टर बाय करेक्टर डालना, उसका जो रिजल्ट निकलेगा वो एक न्यूमेरिकल वैल्यू आ जाएगा. दैट कुड बी इंटीजर वैल्यू, लेट्स से x, मेक इट x plus 3, and again you will get another integer value, and to convert that integer value आप chr एक मेथड लगता है, chr ब्रैकेट में एक न्यूमेरिकल वैल्यू डाल दोगे तो वो स्काई कोड रियल डेटा टेक्स्ट आपको प्रिंट कर देगा. सो आपको वहां पे बस chr फंक्शंस और एक ASC फंक्शंस का यूज करना है, एंड प्लेसिंग द डेटा इनटू द लूप एंड हैंडलिंग दैट डेटा. दैट्स इट. सी में ऐसे ही पास्कल, पाइथन, PHP, or why not any common language, Python में, R language में, wherever you are comfortable you can identify, and you are quite easy to make those both the methods, right? And you can further run those methods. तो ये practical question आ जाता है कई बारी. You're right. Is that clear? Next, I want to show you some more ways how we can create our cryptographic algorithms. Can we make private public key by own? Actually, private public key must be issued to you from your certifying authorities. There are many registered under MCA, Ministry of Corporate Affairs in India. There are many certifying authorities are there who provide the digital signature certificate. आजकल डिजिटल सिग्नेचर सर्टिफिकेट्स आते हैं. डिजिटल सिग्नेचर सर्टिफिकेट्स कैसे होते हैं, अगर आपने कभी देखा हो तो DSC लिखेंगे ना आप गूगल पे, तो आपको एक पेन ड्राइव जैसा कुछ लुक आएगा. ये देखिए DSC लिखेंगे, ठीक है, दैट इज डिजिटल सिग्नेचर सर्टिफिकेट. इसकी मैं अगर इमेजेस कहीं चेक करूं, सो यू विल फाइंड सम डोंगल्स, USB डोंगल्स, राइट? इट सीम्स टू बी लाइक दिस. दिस इज व्हाट योर DSC is. There you will find DSC, Digital Signature Certificate. It is a complete asymmetric cryptographic product, okay, and which carries your private and public key in these dongles. तो इन्हीं dongles के अंदर आपको आपके private और public keys होते हैं. Okay, there you will find these dongles. इसी में आपको private key, public key मिलेगा. ये regular pen drive नहीं है. These are certifying DSCs हैं. According to IT Act Amendment 2008, Section 35A explain the detail about DSCs. Digital Signature Certificate होते क्या है? IT Act Amendment 2008 Section 35A में लिखा है, तो आप पढ़ सकते हो. Right? What is this dongles all about? So in this dongle, basically that is to be issued to you from your some certifying authorities, and those certifying authorities being issued and being prepared by generally MCA, that is the Ministry of Corporate Affairs, and globally there are many certifying authorities are available. Okay, so from any certifying authority you are supposed to buy the dongle for your name, जिसमें आपका ऑडियो वीडियो रिकॉर्डिंग करते हैं आजकल ऑनलाइन प्रोसेस में, आपका बायोमेट्रिक्स, डिजिटल सारी डिटेल्स, आपकी वॉइस रिकॉग्निशन 10 सेकेंड्स का वॉइस वो लोग रिकॉर्ड करते हैं, योर नेम, योर नंबर, एंड द रिक्वेस्ट दैट आई एम विलिंग टू बाय DSC, प्लीज अलॉट मी. सो दे विल अलॉट यू ऑन डिजिटल certificates, digital signature certificate, DSCs, and by using those DSCs you can participate in online tendering. जितना भी E-governance projects आ गए गवर्नमेंट ऑफ इंडिया में, अगर आपको कोई भी ऑनलाइन सबमिशन करना है, कोई टेंडर है, आपको जीएसटी रिटर्न फाइल करना है कंपनी के बिहाफ पे, इनकम टैक्स रिटर्न है ना, पेटेंट्स, कॉपीराइट्स कुछ अप्लाई करना है, everywhere these digital signatures are applicable, DSCs are applicable. Okay, but my concern is I want to secure my data, and these DSCs are quite paid and little expensive also. हालांकि ज़्यादा expense नहीं है, but हैं, ठीक है. Why to unnecessary as a student? Why you want to spend on some amount if it is not necessary for you? Because there is a limitation. It is valid for 1 year, 2 year, or 3 year maximum down the line. अलग अलग क्लास के सर्टिफिकेट्स आते हैं, क्लास ए, क्लास बी, ऐसे अलग से क्लास सी. हालांकि बाकी सब बंद हो गए हैं अभी, कॉमन क्लासेस चल रही हैं बस. तो आपको सर्टिफिकेट्स मिलेंगे जिसे हम डिजिटल सिग्नेचर सर्टिफिकेट्स कहते हैं, डीएससीज कहते हैं. एंड देयर यू विल फाइंड 2 कीज. उसको रन करने के लिए, कनेक्ट करने के लिए, ये सब क्या है, यूएसबी टोकन्स हैं. these all are called as USB tokens. These are not the USB drives. इसमें ये नहीं कि चलो मेरे डिजिटल सिग्नेचर भी रहेंगे, चलो मैं और डेटा भी सेव कर लूंगा, ऐसा नहीं होगा. These tokens being accessed by जो भी आपने CA या जो भी डिस्ट्रीब्यूटर है, आपने किसी डिस्ट्रीब्यूटर से लिया है तो डिस्ट्रीब्यूटर prepared their softwares and you need to deploy those softwares in your computer, connect your DSC, that open that software, and that software helps you to encrypt, apply your signatures in PDF file, right, और many other files and so on. हम लोग जब कोटेशंस वगैरह भेजते हैं या हम लोग ऑनलाइन पेमेंट्स करते हैं तो हम लोग अपना DSCs लगाते हैं, राइट. कभी आपने वो देखा है आधार कार्ड वगैरह डाउनलोड किया अपना ऑनलाइन? अगर आपने आधार कार्ड डाउनलोड किया होगा तो उसमें आपने देखा होगा देयर इज अगेन अ डिजिटल सिग्नेचर ऑफ सम सेक्शन ऑफिसर ओवर देयर. तो डिजिटल सिग्नेचर्स लगाना जरूरी है ना, क्योंकि उस डॉक्यूमेंट की ऑथेंटिसिटी क्या है, दैट बीइंग डिप्लॉयड बाय द डिजिटल सिग्नेचर्स. इज दैट क्लियर? तो डिजिटल सिग्नेचर्स बनते हैं इस तरीके से, अप्लाई किए जा सकते हैं किसी भी डॉक्यूमेंट में. लेकिन देयर इज अ लीगल कंसेप्ट बिहाइंड दैट. एक ये कीवर्ड आता है एग्जाम में, बार बार आता है. व्हाट डू यू मीन बाय द कंसेप्ट ऑफ नॉन रेपुडिएशन? नोट डाउन, व्हाट इज इट? It is called as non-repudiation model. What is non-repudiation? Non-repudiation means anywhere where you applied your DSCs, जहां जहां आपने DSCs apply करे हैं, you cannot say no that such signatures being not applied by you. You cannot deny your signatures. Whatever the consequences are there, you have to bear it. So before you apply any digital signatures, make sure your signatures must be authentic, valid, and under your supervision. At least you can submit or apply your signatures on any documents. मैं पीछे CA के पास गया था, one of my friend CA, he is chartered accountant, not certifying authority, he is a chartered accountant. तो please CA chartered accountant अलग है, अकाउंटिंग की भाषा में मत सोचना. This is IT. In IT we need CA, and those CAs are what? Certifying authorities. They are not chartered accountant, they are certifying authorities, right? There are some organizations who provide you DSCs to individuals, kind of a distributors authorized by the government. Okay, so I went to one of my CA chartered accountant, और वो companies के वो करते हैं ना फाइलिंग, या मार्च का टाइम था जैसे, तो all were on to it. I have seen उनका एक इंटर्न आया, आके कहता सर उसकी रिटर्न फाइल करना है, वो कुछ करना है, तो प्लीज आप मुझे उसका DSC दे दो. तो वो कहता हाँ ले लो. कैन यू इमेजिन, दे हैव अ बिग ड्रॉर में से उसने इतना बड़ा पैकेट निकाला जिसमें बंच ऑफ DSCs, मतलब मोर देन आई बिलीव 200 प्लस पेन ड्राइव्स निकली. तो मैंने कहा भाई क्या क्या तुम लोग नेहरू प्लेस बैठे रहते हो क्या, पेन ड्राइव इकट्ठे करते हो? Then he said, no, sir, these are not the pen drive. These all are tokens, USB token. These all are digital signatures. तो मैंने कहा क्या दुनिया को लूटने का इरादा है क्या? 200 प्लस, मतलब if your clientage is more than 200 companies and their CEOs, their directors, उनके डिजिटल सिग्नेचर सर्टिफिकेट आपके पास पड़े हैं, और उनका एक इंटर्न आया और आगे कहता है मुझे रिटर्न फाइल करना है, उसका DSC दे दो सर. So they took that DSC, applied that DSC and filed the return. अरे इंटर्न है, अगर उसने गलती कर दी, कोई प्रॉब्लम हो गई, कोई फिगर गलत कर दिया, कुछ भी इनकरेक्ट और पार्शियली इनकरेक्ट और इनकम्प्लीट डेटा ट्रांसमिट कर दिया, सबमिट हो गया, देन हु विल बी लायबल? अरे एज पर नॉन रेपुडिएशन द कंपनी ओनर इज लायबल, द सिग्नेचर होल्डर इज लायबल. आपको अपने ये जो है ना यूएसबीज ये वाले, यू हैव टू सेव इट लाइक इवन मोर देन लाइक योर पासपोर्ट्स. ये आपके डिजिटल सिग्नेचर्स हैं. एंड एज पर लॉ which is called as a special keyword called non-repudiation. If you applied your digital signature anywhere on the document, you're not supposed to say no, that such signatures never being applied by you. तो वहां पर तो ये सीए लोग क्या करते हैं, सभी डायरेक्टर्स के कहते हैं अरे बार बार आपको तंग नहीं करेंगे, अपना डीएससी बना के हमें दे दो एंड हम आपकी रिटर्न वगैरह सब फाइल कर देंगे, आप ऐश करो. एक थोड़ा से कंफर्ट के लिए सारे डायरेक्टर्स, मतलब 200 प्लस डायरेक्टर्स ने अपने अपने डिजिटल सिग्नेचर्स एक सीए को दिए हुए हैं, और सीए खुद तो काम कर नहीं रहा, उसके इंटर्न्स काम कर रहे हैं. सो मैंने कहा अरे भाई अगर उसने मिस्टेक कर दी तो कहता सर हमारा क्या फर्क पड़ रहा है, अगर कोई केस आएगा, स्कूटनी में आएगा, कोई इशू आएगा, कोई दिक्कत आएगी तो क्लाइंट को आएगी, तो क्लाइंट को आएगी तो उसको ठीक करने का भी पैसा मिलेगा, आज रिटर्न फाइल करने का भी पैसा मिल रहा है. तो दोनों केसेस में हम तो विन विन सिचुएशन में, तो हमें कोई फर्क नहीं पड़ता, बिकॉज सिग्नेचर्स आर ऑफ दोज डायरेक्टर्स. सो मेक श्योर आपके भी कहीं कंपनी में कोई ऐसा है, तो यू आर नॉट सपोज टू, और आप में से भी कोई ऐसा है कि दैट यू शेयर योर डिजिटल सिग्नेचर सर्टिफिकेट्स with your accounting people, then make sure you should not do this, because they are supposed to handle it. अभी होगा रिटर्न फाइल करने का टाइम आ गया ना, आगे इतना क्राउड हो जाएगा, ओवरलोडेड होंगे अकाउंट्स वाले, और अकाउंट्स वाले जो हैं आपका गलती से भी अगर उन्होंने कोई गलती कर दी और अगर आपका डीएससी लगा दिया, देन यू विल बी गोइंग टू बेयर दैट consequences whatever. so आप ये नहीं कह सकते अरे मैंने नहीं किया, मेरे सीए ने किया. सीए इज रिप्रेजेंटेटिव ऑफ यू, सो सीए इज नॉट लायबल, यू आर लायबल, राइट. आप कोई टेंडर गलत भर देते हो, कुछ आपका कोटेशन गलत हो जाता है, कोई वैल्यू प्लस माइनस हो जाती है, गलती से जीरो एक एक्स्ट्रा लग गया या एक कम लग गया, तो यू आर रिस्पॉन्सिबल, एंड दैट इज नॉट रिवर्सिबल. दैट डॉक्यूमेंट इज नॉट रिवर्सिबल. वॉट एवर द consequences comes across, you will be liable for that. So please try and understand and make sure before you apply your digital signature certificates in your organization, or because you are representing to any organizations. ये किसी कंपनी को इशू नहीं होते, कंपनी के जो डायरेक्टर्स हैं उनको इशू होते हैं, बिकॉज दे आर द रिप्रेजेंटेटिव ऑफ द कंपनीज. क्लियर हो गया डीएससीज क्या होते हैं. अब ऐसे ही अगर मुझे अपना डेटा ट्रांसफर करना है, आई वांट टू ट्रांसफर माय डेटा, I want to control my data, और उसमें मुझे डिजिटल प्राइमरी की पब्लिक की का कॉन्सेप्ट लगाना है. हाउ कैन आई अप्लाई माय प्राइवेट पब्लिक की कॉन्सेप्ट, असिमेट्रिक क्रिप्टोग्राफी कॉन्सेप्ट. सो ऐसे में हम लोग क्या करते हैं, एंड एज आई आस्क यू व्हाई यू सपोज टू अपलोड योर डेटा इन द गूगल क्लाउड और एप्पल क्लाउड और सो, वो भी तो आपका डेटा मिसयूज करेंगे. सो व्हाट इज द बेस्ट प्रैक्टिस, हाउ आई यूज गूगल क्लाउड. I would like to share something of real practical to all of you. You can take a look. हम लोग कैसे इस तरह से डेटा को हैंडल करते हैं. Okay, I'll just give me a minute. Yeah. ये देख रहे हैं आप. I have a concept of some private key, some public keys. ये रही मेरी private key, ये रही मेरी public key. पैम फाइल्स बनाई हुई है मैंने, जिसमें मेरा कुछ डेटा रहता है, अलग अलग अपना डेटा है, और वो डेटा को मैं क्या करता हूँ, ये मेरा सपोज डेटा है, आप देख रहे हैं बहुत सारा मेरा डेटा है, ये सारा डेटा को एक फोल्डर में है, फोल्डर को मैंने एक जिप फाइल बना दिया. सो फर्स्ट आई अप्लाइड द कंप्रेशन टेक्निक ऑन इट. आफ्टर कंप्रेसिंग आई प्रिपेयर्ड वन सिंगल फाइल, and now on that single file, by using my customized private public key, I try to encrypt that data. And can you see the size of the data encryption is 100% same. साइज नहीं फर्क होगा encrypt करने से. कंप्रेस जो करा है वो पहले, कंप्रेशन करेंगे तो साइज कंप्रेस होगा, बट इंक्रिप्ट करेंगे तो साइज कंप्रेस नहीं होगा, द साइज इज सेम, राइट? So I applied a signature and I generated the encrypted content. So this is my zip file which is encrypted by using my private public key model. तो मैंने प्राइवेट की लगा के इसको इंक्रिप्ट कर दिया एंड आई विल अपलोड दिस मॉडल एनीवेयर इन द गूगल क्लाउड डिस्क स्पेस, है ना, गूगल ड्राइव या एप्पल ड्राइव या जो भी ड्राइव्स हैं आपके पास, एनी क्लाउड ड्राइव. So I'll keep my data in this encryption standard because even Google cannot extract my data unless and until they don't have my private key. So I need to use my private key. Without my private key, nobody can extract my data from such methods. Right? What is the best practice? Just take a look. Because I'm using Linux, I use one of the method. आप लोग ऑनलाइन भी देख सकते हैं और ये किट टूल किट है. तो प्रैक्टिकल करने का तरीका क्या है, एक टूल किट आप देख सकते हो, ये आपको मैंने ऊपर गिटहब का एक लिंक भी दिया है अगर आप देखना चाहें. तो ये मेरा एक मेथड है, जैसे मैं प्राइवेट पब्लिक की जनरेट करता हूँ. आई एम यूजिंग द मेथड कॉल्ड ओपन एसएसएल. क्या यूज करता हूँ? ओपन एसएसएल. द इंक्रिप्शन टेक्निक इज X509 स्टैंडर्ड यूज कर रहा हूँ, रिक्वायर्ड X509 स्टैंडर्ड. और इसमें 1 लाख डेज के लिए, क्योंकि एक मैंने बताया ना लिमिट होता है 1 ईयर 2 ईयर 3 ईयर्स, अगर आप परचेज करते हो, है ना, सर्टिफिकेट्स फ्रॉम सम अथॉरिटी, सो देयर इज अ पीरियड एक्सपायरी डेट. लेकिन ये तो मैं खुद बना रहा हूँ, तो मैंने अपने लिए क्या किया, 1 लाख डेज का एक की जनरेट कर दिया बाय यूजिंग RSA 8K. कैन यू सी दिस? आई यूज RSA 8K टेक्नोलॉजी इंक्रिप्शन. और की आउट किस में आएगा? एक फाइल बनेगी प्राइवेट और उसका जो आउटपुट आएगा, एक सर्टिफिकेट पब्लिक आउटपुट जो बनेगा वो बनेगा certificate.pem. So in other way I got two files, one is private key.pem and second key is certificate.pem. So I'm using these two keys, and based on these two keys I am going to encrypt my data. So you can see I have private key, I have public key. कंसेप्ट समझ में आया? दो कीज कौन सी हैं? प्राइवेट पब्लिक कीज. Now if I get this data, private and public key, now further let us encrypt some file. I have a data and how to encrypt and decrypt. Let's see that. So once you can able to prepare this, जब preparation होगा, सबसे पहले ये की लगाने के बाद भी पासवर्ड डालना है. So you can generate a passphrase or you can avoid also in case if you want. Afterwards you can type your some more details like country, state, location, है ना, जो जो आपको लिखना है you can write. Afterwards then encrypt a file. How to encrypt a file? I'll use OpenSSL S-MIME data because ये मेरा system MIME data है, इसको मैं बाइनरी फॉर्म में लेके चलता हूँ, क्योंकि कोई भी फाइल होगी बाइनरी में लो ज़्यादा बेटर है. So I'm using it as a S-MIME data, and what I want to encrypt my data. Consider my data as a binary data where I'm using AES 256 algorithm. So की जब अप्लाई करूंगा, जब की अप्लाई होगा that is RSA, ठीक है. लेकिन जो डेटा पे इंक्रिप्शन होगा वो कौन सा होगा? डेटा जो सिक्योर कर रहा हूँ वो लगा रहा हूँ मैं कौन सा? AES 256 bits. So this is one of my algorithm which is AES 256 bits which I am going to apply. Input file कौन सी है मेरी? Plain file.zip file. कोई भी आपकी zip file होगी. और आउटपुट क्या बन जाए? आउटपुट फाइल जो निकल के आएगी वो क्या होगा? इंक्रिप्टेड वाली zip file.enc. enc मैंने एक्सटेंशन डाला है, आप कुछ भी डाल सकते हो. Even you can keep it like zip file, but you should remember what you are doing, right? So this is a customized report. Like I created another output file that is the enc मैंने बनाया, output form der, and now you have to use your ssl certificate.pem file. आपको अपना SSL सर्टिफिकेट लगाना है. तो जब आप अपना SSL PEM फाइल को यूज करेंगे, RSA एल्गोरिथम विद AES इंक्रिप्शन का यूज करके वी आर गोइंग टू इंक्रिप्ट माय डेटा. अब इसमें इंक्रिप्शन मेथड है. इंक्रिप्शन मेथड में आपको एल्गोरिथम चाहिए थी, आपको प्लेन फाइल चाहिए थी, प्लेन डेटा चाहिए था, एंड आपको की चाहिए थी. लॉजिक समझ में आया? ये वाला मेथड समझ में आया? इंक्रिप्शन मेथड में आपको प्लेन टेक्स्ट चाहिए था, एल्गोरिथम चाहिए था, की चाहिए थी. देन ओनली यू कैन क्रिएट द साइफर टेक्स्ट. So same way I use these three things. I use a algorithm, consideration of my data, so the format of my data is in the binary form. The method which I want to use is encryption using this tool called OpenSSL. Input as my plain text, so my zip file, and output whatever being generated you want, whatever the output you want. This is my ciphertext, and in this ciphertext, my keys which I'm using, because I have to apply the keys, I'm using asymmetric cryptographic keys, RS algorithm generated cryptographies. So I use my key, and at this time, once I use my key, finally you will get your data. ठीक है, आपका डेटा इस तरह से जनरेट हो जाएगा. एंड इन केस ऑफ decryption, once you are in decryption, then in case of decryption file you have to use, अब destination पे डेटा क्या भेजोगे आप, सी है ना, encrypted.zip.enc फाइल भेजेंगे. बट नाउ है ना, नाउ I want to decrypt on the destination side. Now on the destination side, again you have to use the same tool like OpenSSL, consideration of the data format, decrypt method, binary format. अब input में क्या लेंगे, ciphertext. So this is your ciphertext, encrypted file. ठीक है, इनपुट फॉर्म, आउटपुट जनरेट जो होगा वो किस फॉर्म में होना चाहिए, वो जिप फाइल में होना चाहिए. कीज में डीक्रिप्ट करते वक्त आपको आपकी प्राइवेट की चाहिए. डीक्रिप्ट करते वक्त you need your private key. Is that clear? To decrypt करते वक्त you need your private key and the password being applied at the time you compile your file. Same password चाहिए, private key चाहिए. Understood? In this way you will get your data back in your zip file and आगे zip file को uncompress कर लो. लॉजिक क्लियर हुआ सबको? Is that clear to all?
Yes, sir.
Perfect. ये एग्जाम में भी आया हुआ है एक क्वेश्चन कि आपको अपनी प्राइवेट पब्लिक की जनरेट करनी है और कोई भी फाइल को लेके उसको इंक्रिप्ट करके दिखाना है बाय यूजिंग एनी टूल एनीथिंग. तो वो ऑनलाइन आपको सपोर्ट मिलता है दैट यू कैन गो एंड डाउनलोड एनी थर्ड पार्टी टूल in case you want. And in that case, the purpose is to generate your private public keys and apply the private public keys on your documents so that you can generate ciphertext. Take my word, this is one of the best technique to really secure your data. लेकिन ध्यान रखना अपनी कीज का, ये ना हो आपका प्राइवेट पब्लिक की भी आप उसके साथ ही डाल दो या ऐसी जगह रखा कि आपसे खुद आपका प्राइवेट पब्लिक की गुम हो गया, तो फिर आप अपना डेटा भी डिक्रिप्ट कभी नहीं कर पाओगे. तो व्हाट इज द बेस्ट प्रैक्टिस टुडे? द सिनेरियो इज बिफोर यू ट्रांसफर एनी डेटा ऑन द क्लाउड. आज बहुत सारे क्लाउड स्टोरेज है एंड एवरीबडी इज यूजिंग क्लाउड स्टोरेज, है ना. यू आर यूजिंग गूगल ड्राइव और एनी अदर ड्राइव, राइट, और माइक्रोसॉफ्ट एज्योर पे भी स्टोरेज है, वन ड्राइव. सो देयर आर मेनी अदर ड्राइव्स. In case you are using a cloud computing to store your data is always in the plain text. So even they got the permission to access your data. What is the right way to use your data and transfer your data? I personally use a Google Drive or OneDrive, cloud drives में, जहाँ पे मेरे बहुत precious data files रहती हैं वहाँ पर. But मैं वो data ऐसे नहीं रखता, कोई भी मेरा data misuse कर लेगा. What is the best practice? I'll first encrypt my data by using these algorithms, and I have only my private and public key with me. Further, I'll encrypt that and post that data, place that data on any Google Drive or any drive. They can't able to recognize what is that data all about. As and when it's required, I will download those files, I will apply these algorithms, right, and I can able to access my data like as it was. अब यहां पर एक क्वेश्चन आता है इसकी इंटीग्रिटी चेक का. समझ में आ रहा है? तो आपने क्रिप्टोग्राफी पढ़ी, सिमेट्रिक क्रिप्टोग्राफी, असिमेट्रिक क्रिप्टोग्राफी पढ़ी, ठीक है. इसके बाद अलग अलग इसकी एप्लीकेशंस हैं. एक एप्लीकेशन का एक वीडियो दिखाता हूं, एक बार वो क्विकली देख लो. और फिर हम बात करेंगे आगे हैश वैल्यू की। आज अगर कर पाएंगे ठीक, नहीं तो नेक्स्ट क्लास में हम हैश वैल्यूज को लेंगे सबसे पहले, ठीक है। सो फर्स्ट यू नीड टू अंडरस्टैंड हाउ इट वर्क्स। एक मैं छोटा सा आपको एक एक्सपेरिमेंट दिखाता हूँ, इन केस इफ आई एम कैरिंग विद मी राइट नाउ। समझ में आ गया सबको सिमेट्रिक एंड असिमेट्रिक क्रिप्टोग्राफी, हाउ यू कैन जनरेट योर प्राइवेट पब्लिक की मॉडल। अदरवाइज गूगल करेंगे तो बहुत सारे थर्ड पार्टी सॉफ्टवेयर्स भी मिल जाएंगे, लेकिन आई यूज ऑथेंटिक वन, जिसके लिए कमर्शियली आई कैन यूज, दैट इज ओपन एसएसएल। मुझे उसके लिए कोई किसी को कुछ पे नहीं करना है, एंड ऑफिशियली आई कैन यूज इट एज एंड व्हेन रिक्वायर्ड, ठीक है। तो मैं कमर्शियली भी उस एप्लीकेशन को यूज कर सकता हूं, क्योंकि ये ओपन सोर्स सॉफ्टवेयर है। दिस इज योर ओपन सोर्स एप्लीकेशन, ठीक है, कॉल्ड ओपन एसएसएल। हाउ टू ऑपरेट ओपन एसएसएल ऑन विंडोज ये आपको देखना पड़ेगा, बट दिस इज ऑन लिनक्स, 100% इज एप्लीकेबल। और ये बस 2 सिंपल लाइंस की कमांड चलाते हैं और हमारा काम हो जाता है। आर यू गेटिंग माय पॉइंट? व्हाट इज द बेस्ट प्रैक्टिस? सो हम लोग कौन से एल्गोरिथम्स लगा रहे हैं, या कौन से एल्गोरिथम लगा रहे हैं, कितने बिट्स के एल्गोरिथम लगा रहे हैं, इसमें ये सारी चीजें क्लियर हो जाती हैं। इज दैट क्लियर? एक और कॉन्सेप्ट लिखिए, एक और एग्जाम में कॉन्सेप्ट आता है स्टेगैनोग्राफी। इट्स अ वेरी वेरी इंपॉर्टेंट क्वेश्चन। जब भी क्रिप्टोग्राफी से रिलेटेड आएगा तो एक और टॉपिक आएगा स्टेगैनोग्राफी। नाउ स्टेगैनोग्राफी is another type of the application of cryptography, right? It's an application, it's like another way to use some more technology, or make it a hybrid technology along with cryptography, called steganography. What is a steganography? ये important question है, लिख लीजिए। Steganography is one of the technique where we generally use to hide our data in the existing multimedia data। multimedia मतलब कोई भी इमेज, कोई भी ऑडियो, वीडियो, या कोई भी थर्ड पार्टी फाइल, मतलब टेक्स्ट बिहाइंड टेक्स्ट, टेक्स्ट बिहाइंड ऑडियो, टेक्स्ट बिहाइंड वीडियो। आई एम नॉट टॉकिंग अबाउट मेटा डेटा, आई एम ट्राइंग टू टॉक अबाउट हाउ टू embed, not linking, not extracting your artifacts. I'm talking about, can we able to embed the data behind any other file। एक फाइल के अंदर हम किसी तरीके से दूसरी फाइल का पूरी पूरी फाइल को छुपा सकते हैं। कैन वी हाइड, कैन वी encrypt, and can we store that entire data within the another multimedia data file, any multimedia data file, where we are not going to corrupt the other file, it is accessible। मतलब in November 2001 this case also happened by Osama bin Laden। I hope आप सब जानते हैं, he was a well known terrorist, being retaliated by the US, है ना, and especially in Pakistan, so US killed Osama bin Laden, right? But Osama was one of the best civil engineer, along with a great IT background. In November 2001, he tried to generate one mail and transfer the mail to the destination, as their mails were always under surveillance, so that got trapped by the law enforcement agencies, and many law enforcement agencies start investigating what is that mail all about. So in that mail, it was nothing but one beautiful girl photograph lands over there. So it plays like one photograph, one image of the girl. Now everybody start thinking, है ना, सब दिमाग के घोड़े दौड़ा रहे हैं और सोच रहे हैं what happened, अरे is it a target, is it a victim, what this girl is going to do, who is this girl, from where she came across, many things. And what actually he did, he just took a pic from internet। वो बेचारे का करियर के लिए ऐसी तैसी होने लगी। So is it a victim, is it a what, like being cross verified? So but Osama took a one image and transfer that image to the destination. So the mathematicians on the back end, some mathematicians who know the concept of grid computing and who know how to work with the pixel analyzing model, they basically investigated, and what they identified that there is a one text file, एक txt file है, right? So there must be a one txt file behind the image. People were trying to open that image, but behind that image there is some text file. So the concept is how to hide the txt file behind any front end file. Could be a audio, mp3, mp4, jpg, png, gif, right? docx, any type of file. So data behind a data, one text file behind another text file, where data, the hidden data is not representable. तो इमेज है, इमेज तो इमेज की तरह लगेगी ना, इट्स अ प्लेन इमेज. आप अगर डबल क्लिक करेंगे यू कैन व्यू दैट इमेज, दैट्स इट. But actually behind that image there was a txt files or some other hidden data, another file, and that file contains some confidential message. So ये renowned way ये था, लेकिन obviously this technology was quite ancient technology, and now try and understand how the thing works on the back end. Such technique called as steganography. क्या कहते हैं वैसे को? That technology called as steganography. My screen is visible to all, na?
Yes, sir.
Good. So okay. I'm just going to share one video to all of you. So basically, what is cryptography? This is a concept of key, lock and key model, right? एक मैं आपको एक क्लिप दिखाने लगा हूँ. Just take a look. Right, this is a AV clip. एक check करो. And in this, I try to use one of the tool called S tools. Basically, that is the application where we try to hide our data behind the image. Okay, that's a purpose of this particular part. So just take a look. So this is a concept called steganography. What is the concept of steganography? Just take a look.
Let us start one of the now what I have to do, let me take some let us start one of the concept of cryptography's application, which was known as steganography. Now, what is steganography? Steganography is one of the techniques where we would like to place the data behind the image, and one image means direction of it.
So what is the image? Generally, we have the image called. Let us try and understand. Let's say what is the concept. The technical concept is there is two major thing. One is object linking, and one is object embedding, right? जिसे हम पहले बोलते थे OLE, OLE, that is object linking and embedding. Now linking means you are going to create a third file where you already have multiple files, two or more files which you want to combine and create the third file. That is linking. But in that case, all the files being linked to each another. The another concept is embedding. Embedding मतलब एक फाइल को nested फाइल बना दो, बिल्कुल डेप्थ में ले जाओ. Example like if you have a MS Word file, MS Word file में अगर आप कोई image डालते हैं, so you just need to carry a docx file, and that docx file being transferred anywhere on the destination, and the moment you open, you will also get that image file also over there. So it is not linked. जैसे HTML में हम लोग hyperlink लगाते हैं, है ना? We are not going to do any hyperlink, anchor tag नहीं लगा रहे हैं. It is the embedded data. We are talking about embedded data. So in this case also we are talking about embedding of the data. Now let us assume we have the image, and image is what? It's a combination and collection of pixels. So there are three good color code RGB, red, green and blue. So the color code always, because it's a 8-bit model, so 8 bits means 0 to 255. So RGB 0 to 255 again for R, for B, as well as for R, for R, G and B. For all three color codes, we have the values from 0 to 255 for each value. Okay, so now the concern is, let us assume if the value is always 0 0 0, 0 for R, green and blue, 0 0 0. If the value is 0 0 0, then what is the color? Then in that case the color code is black. Okay, and if the value of R, G and B is 255 255 255, which is the maximum one, then actually the color code is white. So all the colors lands between 0 to 255, right, in case of the RGB model. Right, now what we want, let's say we'll try to take any image where the image is like I took my company's logo. Why I took this logo, and I use a one software called S Tools. In S Tools, what I did, I just drag and drop my logo image, which is a one of the GIF file. GIF is actually for the animation, but there is no animation in this image. Why I took GIF, why I'm not taking JPG, even I can take PNG, not a problem. So there is a reason, because I want more white spaces. So you can see more white pixels are there. The more white pixels are there within the image, you can store more data behind that, because the concept is we will find the pattern over there, and in this pattern we found the value of each pixel is 255 255 255. So if the value is always 255 255 255, I will reduce the quality of this image, and I'll, let us say I'll make it 250 250 250 to each white pixel, to each white pixel, right? तो अगर मैं एक पिक्सल का अगर 255 255 255 है, अगर मैं उसको 250 250 250 बना देता हूं, in that case I got 15 bits, I got free 15 bits. And ऐसे ही how many pixels are there? You know, lakhs of crores of pixels, billions and millions and billions of pixels are there in the image sometimes, depending upon what image you are selecting. So accordingly, I will try to create a vacated space, so that I'll try to reduce the color quality of those image, especially where you have more white pixels, and will try to generate the gap, will try to generate the empty spaces. And in that empty spaces, we can take any file and convert that file and place that file within those empty spaces. इससे दो चीजें होंगी, आपके इमेज पे कोई इफेक्ट नहीं आएगा, इमेज सीम्स टू बी लाइक सेम, आपको ज्यादा कलर का चेंजेस भी पता नहीं चलेंगे, आपको लगेगा ये वाइट ही है, राइट? रीजन, वो हल्का क्रीमिश कलर आ गया, अगर आ भी गया तो दिस इज माई लोगो, यू कैन नॉट कंपेयर, this is my company's logo. Do you have the same file with you? No, you don't have, right? So I have the file, I am going to create the model, and in this model what I did, I'll try to place the data and try to create another text file, right? एक txt file बनाएंगे और इसमें डालेंगे.
Behind this logo, now I picked this logo again. There is a one reason, because this is the one of the logo where it contains lots of white pixels, white spaces behind this image. Because first of all, it is a GIF file.
लॉजिक समझ में आ रहा है सभी को? What is this all about?
GIF, DMP, PCX kind of file. Better not go for JPG file, because JPG is itself is a condensed file.
So what is the best practice? The best practice is, let us take this file, and now I'm going to take another txt file. So in this part, I'll suppose to create a one notepad and one file where I'll try to place some data. That data is like, this is a hidden data. तो मैंने क्या बनाया, एक this is the hidden data नाम से एक txt file ready कर दी. Okay, so I got a file. So we'll go and just save the file, and once you will go and simply save the file, let's say I'll save it on desktop. Okay, so now we got a one text file. Now what happened, now you have two files, one is GIF file, one is txt file. But Wherever I will transfer, I will only transfer GIF file. I will not transfer TXT file along with that. Okay, but I want to transfer the data. This is what the technology called steganography. So what I'll do, I'll simply drag and drop the TXT file on the image. This is the power of the tool called as tools. It's a steganography tool. So I'll simply pick the TXT file, the data file. Okay, I'll pick this TXT file. I'll just drag it on the image, right? So I'll going to drag this image on this image, and once I'll drag on this image, what happened? The internally, this software will gonna create the blank spaces in the image by using a concept of either color reduction or increase the size of the file. There are two methods. Either you increase the size of the file to increase the quality, or otherwise it's better we'll reduce the quality so that we'll get some vacant spaces, and let us try to place our data behind the vacant spaces, vacant places, right? जनरली हम इसको एक कुछ कॉन्सेप्ट भी बोलते हैं, हेक्साडेसिमल या असेंबली लैंग्वेज अगर आपने पढ़ी है तो देयर इज अ कॉन्सेप्ट कॉल्ड नॉप्स, right? So we'll try to identify the knobs or the vacant spaces within the file, and in that file we'll simply transfer the data and try to embed the data by using the concept of cryptography. Okay, so that cryptography is nothing but we'll try to use the symmetric cryptography so that we can place the data using the architecture of symmetric cryptography. So we want algorithm, we need key, so that all we have to do. All right, this is how we have to work on it. Okay, so this is the way how I drag and drop the file. The moment I drag and drop, it asks for the pass phase, and it also asks for the encryption algorithm. So you can just pass your password, right? Just type your password, whatever the password you want to keep as a key. Okay, so we are using it as a key, and we are using symmetric cryptography. So same password would required for decryption as well. Okay, the same password required for decryption as well. And at the same time, I need to apply any algorithm, right? So there are various different algorithms, like I told you, DES, idea is written already in front of you. You can use that idea. So we have a DES, we can use a triple DS, any one algorithm. We can try any one of that algorithm, right? So this way we'll select any algorithm. Let's say we'll select DES. Right, that is data encryption standard. We have many other like triple DES or IDEA or MDC, and many other algorithms are there. So let's say we'll go with the DES and let's proceed. Once we'll proceed, now finally this tool called S tool will gonna find the file, your text, your image file. So we are getting two options. One is you can increase the color combination, increase the quality, or let us go to the attempt color reduction. So we'll go with the attempt to color reduction model. So we selected that model, attempt to color reduction, and in that it basically going to generate the another file. Now we got another output file. Can you compare both the files? Is there any difference between both the files, where first file is the genuine original file and second file is the file which is stegnode? It's a steganography file, output file of the steganography, where one txt file, one message is behind this image. Okay, so finally we have to save this file, We'll take this file, we'll go and save it. Even you cannot compare from human eye. Okay, is there any difference also? You need a, technically you need a pixel analyzers. Pixel analyzer, and secondly both the files to compare. Then only you can identify okay, what is there behind it. Are you getting my point? So this is the way how it works. So you can find this file. Let us say we'll go and save as. Again इसका नाम दे देते हैं जो भी आपको GIF फाइल जैसे थी तो GIF will create a GIF, right? Let's say it's hidden.gif. So I have a new file, and anytime if you'll go and open this file anywhere in any image application where you can open the images, and simply you will find the simple image. It seems to be like an image. So you can try image viewer or any other application, just double click, you will find the same data as it is in the file. तो आपको पता ही नहीं चलेगा, you will never get to know what happened, what is there behind this image. And there is a probability to save that data, hide the data behind the image. तो मैंने एक image viewer open किया Windows का regular, and I'm trying to open that file over there, and you will see it's like a simple file. You will never face any inconvenience, and see it is like a file just in front of you. So file is ready. Now further on the destination side, you'll take this file, transfer the file, download this file on the destination, open it in again your STools application, drag and drop this file, and out of it further we can able to reveal the data by using the same algorithm and same key, same password, right? ये वाली फाइल थी ना, इन दैट केस आपको सिर्फ ड्रैग एंड ड्रॉप करना है और इस पर राइट क्लिक करना है, इसमें ऑप्शन मिलेगा आपको रिवील. सो यू कैन गो एंड रिवील, एंड रिवील में यू हैव टू सेलेक्ट योर सेम पासवर्ड, same algorithm to extract the original file, and then further only you will get the original file. तो destination पे क्या काम करना है, this is the way. Source पे क्या काम करना है, that's another way. So there are many such third-party tools, codes, and applications are available by which you can even implement steganography, right? So how to analyze the stegnos? Analysis are completely based on the pixels, the size, or will use those files in the reverse engineering model hexadecimal editors we use to identify that any such a data behind those files are there or not. So that's another concept. ये देखिए इसमें से राइट क्लिक किया, रिवील किया, यूजर नेम पासवर्ड डाला तो हमें पता चला अरे देखो टेक्स्ट फाइल है पीछे. Now you again right click to this text file and go to save as, and you can extract your text file out of it. This is the way how on the destination side we can able to reveal the hidden text file, and you will get the exact data whatever you want. Is that clear? ये क्वेश्चन बहुत इंपॉर्टेंट है, एग्जाम्स में आता है, प्रैक्टिकल थ्योरी दोनों लेवल पे आता है. So this is architecture of cryptography. And I hope now the concept is also clear that how we can encrypt our data on the networks and how we transfer it on the networks. तो आज जो networks में almost ये कह लीजिए 90%, 80 to 90% का data, depending upon obviously your work profile and applications, but almost 80 to 90% data is now encrypted on the network layer, right? On your transport layer, according to SI if you want to say, but all your data has already been converted, it's being compiled, right? It is under SSL or any security algorithms, so that you cannot able to reveal your data, could not extract or apply any man in the middle attack, so that your data is always safe and secure, and only you can get the artifacts of that data. कि data जा रहा है, source से जा रहा है, destination पे जा रहा है, कौन सा IP है, कौन सा MAC है, that you can analyze, but you cannot able to reveal what data is going behind that. That's a property of cryptography, right? This is what beauty of cryptography, I would say. Is that clear to all? समझ में आया सभी को? कोई डाउट है? क्वेश्चन?
सर डाउट तो करने के बाद आएंगे ना, ये प्रैक्टिस करेंगे।
हाँ, ऐसे प्रैक्टिकल करने पड़ेंगे रोहित, यू आर राइट। तो आप एक बार ट्राई करो, गूगल करो, एस टूल्स नाम से मैंने टूल यूज किया था, बट देयर आर मेनी स्टेगनोग्राफी टूल्स अवेलेबल, यू कैन ट्राई एनी वन ऑफ दैट। और ये प्रैक्टिकल में क्वेश्चन आ जाता है कई बार दैट यू हैव टू अप्लाई द स्टेगनोग्राफी।
ओके सर।
MSc 21 में आएगा, 22 में आएगा, 23 में आएगा, 24 में आएगा, कहीं पे भी आएगा, क्रिप्टोग्राफी सेम रहेगी, राइट? So that's what, like, I just taught you a one common subject. Hardly matters whether it belongs to 21 MSc 21, MSCI 22, 23, 24. Okay, wherever you have the book, wherever you have a topic called cryptography, please read it thoroughly. तो बड़ा नटशेल में मैंने आपको बताने की कोशिश की how we can go and get into the cryptography and how to retrieve that data from the cryptography. Right? Is that clear?
Yep.
Great. ठीक है जी. So please, I think now it's better you should try at your end, and afterwards, still if you face any inconvenience, so let me know, and I'll help you in other way, like in case you are unable to solve it or work out on it. Right?
Okay sir.
So you can make some more practicals like this, steganography, या अपना कीज जनरेट कीजिए, या रेगुलर DES के टूल्स हैं, AES DES आप अप्लाई करके डेटा एनक्रिप्ट कर सकते हैं. So there are various ways where you can process your cryptographic content. Please remember, and please let me know also whenever we are going to start next session, in the next, whenever we have the schedule for the next class, please let me know. I will start the session with hash values, right? So I will start that session with the hash value, and then you can process what is hash and how to work with the hash values. Basically, it is used for integrity checks and authentication. So how we can implement integrity checks and authentications in the legal system, and how we can preserve, we can data preservation model. We use hash algorithms. We have to learn one more very important topic called salt hashing. Salt hashing एक बहुत important topic है, exam में भी आता है. So we'll talk on that, right? But we'll then talk in the next class. So till then, thank you so much. See you in the next class then, whenever we have a session. Right? Thank you, Manjeet. Thank you for just to recall and to remember me that we have to connect and we are supposed to work. Yash, thank you. Bhaskar ji, okay.
Thank you,
You
sir.
all. Take care. Bye-bye.